Okay, so we're going to learn how to use DeMoivre's theorem to turn or to solve this basically. Okay, the first thing you want to do for these kind of problems is to convert the complex number. Okay. So the way to do that is you have to first graph that number on a complex plane. And basically what that is that the x-axis is the real component and the y-axis is the imaginary. So what you're going to graph is a point here. It's basically the point 2, 3. Okay. So the point is there, and you can make a right triangle out of this by drawing it from the origin, going downward, creating that right angle. Then what this is telling us is that this has a length of 2, base of 2, and a height of 3. And from there, with this right triangle, you can find the angle and the hypotenuse we're going to call r. Okay, so I'm going to solve this here. R equals, basically using Pythagoras' theorem to find the hypotenuse, 2 squared plus 3 squared, which is square root of 13. And for theta, we would use the right triangle trig, SOHCAHTOA. Tangent theta is opposite over adjacent, so that's tangent theta equals 3 over 2. Using the calculator, that is about 0.9. Actually, hold on 1 second. We have to type this in the calculator. Inverse tangent of 3 over 2. I'm going to try something different, actually. I'm just going to leave it like this, okay? Because this is going to be a long decimal number. All right, I want to leave this as is and then push it all in the calculator at once. Once you have these two things, we're ready to use DeMoivre's theorem. And actually, this first step is the first step for many of these problems in this section, where if you're given a complex number, you have to turn the trig form first before using one of the equations. But now we can finally use DeMoivre's theorem, and the equation we're using is this one down here. And so it's actually pretty straightforward. R equals square root of 13. Theta, I'm going to leave it as inverse tangent 3 over 2. The n is the degree of the complex number. Start off as 6. Okay, so that's the power of the complex number. All right, so we have these three things and we're ready to use DeMoivre's theorem. The rest of the way is using your calculator to solve the rest of it. So I'm just literally plugging in to the equation. Now I know this looks really weird, but this will actually, by leaving it like this, it'll give you the most accurate answer in the graphing calculator. So let's take a look. Cosine 6 times inverse tangent of 3 over 2. Okay. Is going to give me 0.92626. And for this part right here, that's going to give me negative 0.37684i. So I don't need these parentheses. I'll just group it like that. And here, you can solve square root 13 to the 6th power, 2197. Okay, so then you distribute 2197 to the real and imaginary component. And end up getting 2035 minus 828i. And that will be the answer you're looking for.